Hello, everyone. Welcome to another episode of the KOI podcast. So, as you know, that we have been doing a series of podcasts highlighting different aspects of geospatial technologies and trying to highlight specifically the research done by early career researchers. Uh, so, in this episode, we are covering another major aspect of remote sensing, which is by far one of the most hot topics, if you want to say, in our research domain. So we are going into the world of LiDAR. So I know that there's a lot of curiosity going into the LiDAR applications nowadays in our industry. And today, specifically, we will learn more about how LiDAR can be applied to forestry applications. So with us, we have today Gunjan Barua. Uh, so he's a PhD candidate in Virginia Tech. And today he will talk to us about a bit about his research and also share a bit about his entrepreneurship journey in remote sensing. So, so without further ado, I'd like to introduce Gunjan and sort of if you want to introduce yourself to our audience.
Thank you, Manojit. First of all, thank you for inviting me in this podcast. I have been following this, and I think you are doing a tremendous job. And I think people should learn more about like what the early career researchers are doing with remote sensing and geospatial technology. And I believe that all of us are really passionate about the environment, so our voice should go out there, and like we should share our knowledge with the world. So, as Monojit mentioned, my name is Gunjan Barua. I'm a PhD candidate at Virginia Tech. I'm doing my PhD in geospatial and environmental analysis program at Virginia Tech. Before that, I finished my master's in geography from the same university, and my undergrad was in urban and regional planning from Khulna University of Engineering and Technology at in Bangladesh. And before coming to grad school, I actually worked in the arena of environmental governance. So I was mostly working in the advocacy sector, project management, specifically on water sanitation, hygiene, and also like some poverty reduction programs as well. And but I was always more like a data person, so I kind of like decided to pursue my grad studies and focus more into like how we can incorporate like geospatial data and also geospatial data science for data-driven decision-making tools. And yeah, that's where I am. I kind of never imagined to work directly into the forestry arena, but it seems fascinating, and I hope to share my journey
Right.
with you all today.
Yeah, thank you so much for sharing that. As you mentioned that we all sort of have a different, diverse career trajectory, and and we have covered this in our last episodes as well. That we sort of end up in sort of situations and then sort of try to make the best out of it. So, yeah, and as I know personally that. You have recently become a PhD candidate, so congratulations to you.
Thank you.
So sort of like we'd like to know a bit more about your research, specifically what you're doing as part of your PhD. If you want to tell us a bit about that. In general,
Sure,
I'm
sure.
aware that you're working with LiDAR, and specifically in the forestry sector. But if you just want to break it down for our audience and sort of share a bit
Sure,
more.
sure, I'd love to. So let me share my screen. I have prepared a presentation. I have a very big title, but this is like my whole dissertation title. So what I'm basically trying to do is like I'm trying to predict yield of a specific species that is like the scientific name is here, which is like called Pinus teida, or like which is commonly known as like loblolly pine. And I'm trying to incorporate LiDAR-derived variables and into artificial intelligence, and trying to predict the yield of loblolly pine. And by yield, I basically mean by like what kind of timber someone can get like after a certain period after it's planted. And yeah, let's dive deeper into it. Like, first of all, let me just sh like share what my species is, and it may not be common to everyone. So, Pinus teeter or loblolly pine is basically a very common species across the southeastern United States, and it's spread across like 29 million acres across within the southern United States. And this is the most commercially important species in the southern United States, and it's mostly used for construction materials. You can get produce furnitures, and you can get paper products as well. And one of the other reasons that is like why this species is very important is that it has a like a very smooth structure, so that it's easier for the timber producers to make a different make different timber products out of it. And this is a very fast growing tree, so
Mhm.
it's very commercial. It's commercially viable. So the other thing is that like for in the forestry arena, like it's very important to measure the trees, like how they are growing, and there is a vast field called forest biometrics. So usually what happens is that the foresters go out in the field and they establish some uh, plots, and they measure those trees. They measure the heights, they measure the diameter at the breast height, which is basically diameter of the trees at 4.5 feet from the ground. And based on that, they can kind of calculate like what amount of timber volume they can get from an individual tree. And since there are, as I mentioned, there are like 29 million acres across the
Mhm.
southern United States, it's kind of like impossible to measure all the trees
Right.
within a forest stand.
Mhm.
So what they do is like they get this sample estimates, and they kind of get an idea about like per unit volume acre they can get from the stand. Like let's say, for example, like they can get 100 cubic feet per acre
Mhm.
from a stand. So these are like some of the example estimates. So the uncertainty is that like when we are using like this type of like sample estimates, they have lots of data uncertainty. So that's why like I focus my research on like how we can utilize LiDAR for accurately estimating individual tree level timber volume estimate after certain years. And yeah, so that's what I'm doing here. So I have two major components, two major variables for like predicting the tree volume. So one is the individual tree crown metrics, and another one is the competition index. So let me talk a little bit about like what does individual tree crown metrics mean. So individual tree crown metrics is basically three-dimensional characteristics of individual tree crowns obtained. So imagine this, like the image you can see here. Imagine this is a point cloud of a loblolly pine. And this can be uh, sorry. Yeah, so this can be the crown area. So this is the height of the total tree, and this is the crown height of an individual tree, and this can be the crown area or volume of an individual tree. And you can also calculate, like you can also detect like whether there is any understory present or not below the tree canopy. So using these variables are kind of like important because this kind of gives us an idea about the structural attributes of an individual tree, which can be later used for individual tree level yield prediction. And the competition index, or there are like two types of competition index. There is like one is distance dependent and another one is independent. So I'm focusing on distance dependent competition indices. So it's basically a measure that is used to assess the competitive interaction among trees in a forest stand. So
Okay.
basically, when there are like lots of trees in a forest stand, they are always competing for resources. And by resources, we mean by like they are competing for like nutritional resources in the soil. They are fighting for water. They are fighting for light even.
Yes.
So it's kind of like important for us to know that how the trees are competing against each other, and if we can mathematically convert them, then we can actually understand how the trees grow, they survive, and how their volume is influenced by their neighboring trees. Because if you look at the forest stands, even if all the trees are planted at the exact same time, their growth is their growth may be different, because they're competing for resources in a different way. So
Right.
it's like, so to understand the tree growth prediction, it's important to know how they're competing for resources.
Right.
So so I have two approaches for research. So my first approach is like LiDAR based yield prediction, and the second approach is multispectral remote sensing based yield prediction, which is basically satellite remote sensing based yield
Mm.
prediction. So, so this is kind of like the overall idea of my whole dissertation research, my PhD research. So, in so for the data input, on the data input side, I have LiDAR data and I have optical remote sensing data. I utilize data from Landsat, Sentinel data. So the difference is that uh, when I am using LiDAR data, it's basically using the structural information of a tree. Like, it's giving
Right.
us the structural information.
Mhm.
And on the other hand, the optical remote sensing is basically providing us with physiological knowledge of the trees. Like, I think everybody is familiar with NDVI
Yeah.
or NDWI. So
Right.
this indices kind of gives us information about like the tree physiology, and they also influence growth as well. So I'm
Mhm.
trying to see in a different way, like how LiDAR is influencing the yield modeling, how physiological information is influencing the yield modeling, and
Yeah.
what happens if we combine them as well.
Right.
So so when we are trying to predict the yield, there are like the data is like so diverse, and the interaction between these variables are like so diverse. It's kind of like hard to fit them into linear models, which are easier to implement. So that's where the artificial intelligence, machine learning, deep learning comes in, because they do not have any assumption of the data that the data needs to have some sort of relationship. They
Yeah.
they are not considering any of them, so it's easier. So it's logical to use like machine learning models or deep learning models for this specific type of variables, and to model the yield.
Yeah.
So yeah, so this is my first project. This is an overview of my first project. So basically, I talked about individual tree crown metrics and competition indices that I'm getting from LiDAR data, and I'm infusing it into machine learning models for modeling the yield.
Mhm.
I have also like incorporated a multiple linear regression here, because multiple linear regression, like any type of like parametric models, are
Mhm.
easier to understand, and the results are explainable, while
Mhm.
when we are using machine learning models or like deep learning models, it kind of feels like a black box.
Right.
And we also need to establish that the multiple linear regression or the parametric models are not working properly. So that's why
Okay.
we need to introduce machine learning here. We need to increase the complexity here, so that we
Right.
can have efficient estimate of timber volume from forest stands. So this is kind of like an overview of my first project.
Okay.
And in my second project, so in my first project, I have like a very controlled data set, and like I have I'm working with a very limited amount of data to perfect the modeling approach. But does it actually work? Does it actually work in other sites? So that's where
Mhm.
my second project comes in, where I'm trying to assess the transferability of the models. So I would still use LiDAR data, and I would use study sites the outside outside my project one study areas, and I'll try to introduce the pre-trained model from the project one and implement it to see how the prediction model
Right.
works.
Mhm.
So yeah, so this is my second
Okay.
project, and
Yeah.
my third project is basically basically using like how we can use uh, satellite remote sensing data from Landsat and Sentinel, and how we can incorporate it into some neural network model for stem volume prediction. So the reason of like my motivation for doing this was like flying LiDAR data can be expensive and it still
Right.
takes like a lot of resources, a lot of manpower to
Mhm.
implement it in the field. But while on the other hand, like if we can use like Landsat data or Sentinel data, these data are like freely available,
Right.
and we can incorporate like the time series data for to see like what will happen, like let's say after 4 years or 5 years, and
Yeah.
what will be the timber estimates of them. And the other thing is that there are like lots of private forest landowners in the US. So they often have to rely on consulting foresters
Mhm.
to get an estimate of like how much timber they can get from their lands. But they always and but like connecting to those consulting foresters and also like hiring them and doing some assessments on their lands can be expensive as well.
Yeah.
So that's why like if we can uh, figure out a way to use the open source data
Right.
to get a timber volume estimates, it's going to be like I personally feel like it's going to be
Right.
very helpful for them to get like an investment estimate
Mhm.
from their lands. So yeah,
Right.
so this is my third project. So yeah, so that's that's all from my side.
Right. First of all, thank you so much. That was such a comprehensive sort of background of your whole project. I think for me, one of the key pointers was that how well thought out the project was in terms of your thinking in uh, both not only for the LiDAR, but also thinking in long term in terms of the multispectral applications. Great job on that.
Thank you.
So I had a few questions. Well, I have a couple of them, but I'll try to keep it to two.
Sure.
So so one question I had is like uh, so when you're talking about LiDAR data, is this sort of data coming from sort of like a survey that you did, or is it something that you can get out of a repository or
Oh,
uh,
so yeah, I should have clarified that. So basically, it's coming from like a survey data, like a drone survey data.
okay.
So usually, like when people are doing that, they're doing it in two ways, actually three ways.
Okay.
One is the drone, like drone is the most used mode of collecting LiDAR data.
Yeah.
Another one is airborne LiDAR data. So drone is also airborne, but the airborne LiDAR data, what we usually mean is that it's flown by an aircraft and
Okay.
at a much higher altitude.
Higher altitude.
So the difference is that, like, when we are flying it at a higher altitude, that means we have lower resolution of the LiDAR data.
Right.
And forests can be very complex. Like
Mhm.
the plantations where you maintain the planting density of the trees, uh, it may be kind of easier to detect the individual trees from the LiDAR data. But when we are working with like natural forests,
Right.
I'm pretty sure everybody has at least walked once through a
Yeah.
light through a
Mhm.
natural forest, like in the trails, and it's very complex because there
Right.
are like there are like trees which are at an old growth stage, some trees which are like at the mid story, what we
Right.
say like in the mid story, and there are like always like some understory trees, grass, and like weeds. There are like lots
Mhm.
of things available, and whenever we are using the LiDAR data, all of this data gets captured, and
Right.
it's very important to have higher resolution of the data so that we can delineate the different types of vegetation within in a forest area and get what we actually want.
Right.
So yeah, but like the airborne LiDAR data is still used because when you have like a very large area, using airborne LiDAR data is much more logical, where drone LiDAR data is like it may be effective for small areas, but when you have unlimited resources, like I was recently talking with someone who has a like a $150,000 worth of drone and they are flying it. I
Wow.
was like, okay,
Yeah.
like if you don't have any limitation on the
Yeah.
resources, you can use whatever you
Yeah.
want.
Exactly. Yeah.
And yeah, and the third type of LiDAR data is terrestrial LiDAR. So
Mhm.
terrestrial LiDAR is also usually what people do is like people put it in the backpack and
Right.
they walk through the forest area and get a scan of the whole forest area. But
Right.
it also doesn't address the challenge that usually the like the sample field measurements are having, that you cannot walk the whole forest area.
Right.
You're
Right.
still doing a sample of it.
Right.
But yeah, these are the three major
Right.
LiDAR data collection that
Ways
are,
of collecting the
yeah,
data.
ways
Yeah.
of collecting the data.
No,
Yep.
yeah, that's perfect. That's what I was looking for. The next question is like I was really happy to see sort of you talk about uh why you were using artificial intelligence. I think that's a part that I think it's also for our listeners as well. Sometimes, as you said, that artificial intelligence or the application of AI is sort of like it's sort of taken, I would say, as sort of like a very advanced thing because it's called artificial intelligence.
It's
But it's
become a
great
trendy
how,
thing right
yeah, it's
now.
a trendy thing, right? So, but it was great how you were talking about why exactly why in your case you're using the data. I think this
Right.
has like I totally understand that when you're working with LiDAR data, which is definitely very heavy or storage heavy data sets, that's also one part of it. But it's also I'd like to sort of for you to sort of emphasize more on that. Like when you use an artificial intelligence, like uh, we should definitely like think twice about whether we actually want to
Right.
need to use it or not, right?
Right. Yeah. So my logic is that and also like I have had like very long discussions with my advisors and other professors as well, like to like the need for justifying the use of machine learning or
Mhm.
neural network or overall
Right.
the field of artificial intelligence in
Mhm.
here. So first of all, there has been like years of research, decades of research into this, like in the field of like forestry or in agriculture or maybe even in hydrology or whatever the
Right.
environmental field is, where they have not been using the any sort of machine learning techniques or artificial
Right.
intelligence techniques over there. So they have developed like parametric models and non like lots of modeling. They already have some established modeling approach in there. So I know that like this modeling approach comes with some sort of assumptions, but like these assumptions are like still true. Like
Right.
for example, like if you are considering a tree growth, it's like the tree growth always has a positive relationship with, let's say, age or the diameter at the breast height. So these
Mhm.
relationships are not going away.
Right.
What
Right.
coming what new thing is getting introduced is that we are right now we are trying to incorporate newer technologies, and with our fancy technologies and like some and also like newer mathematical approaches, we are trying to introduce newer variables in there, so that which variables do not actually fit into those established equation. So
Mhm.
first of all, I think like like it was my approach as well, like first of all try to see like whether these variables can be fitted into the traditional equations or not.
Mhm.
If it doesn't work out, then okay, so I don't have any other resources to use, then okay, fine, then like my next approach was to introduce machine learning approaches, because it doesn't consider any assumptions, and also like it can have handle complex data, and it can also handle like large amount of data. So yeah, and I always prefer like uh, combining the approaches,
Right.
like because these equations are like very well established, and like
Mhm.
plenty of researchers have spent
Right.
years for
Right.
establishing those equations.
Mhm.
So these understanding is very important.
Right.
So
Of course.
before understanding that, nobody should directly dig into like machine learning just because it's
Right.
trendy.
exactly.
or like everybody is doing it.
Yeah.
So you
Because
need to
I feel
understand those
like
relationships
nowadays
first.
it's very sort of accessible to sort
Right,
of apply deep. Well,
right,
I won't say it's very accessible, but if you do a bit of digging,
right,
it's possible to apply an artificial intelligence. But having said that, like really understanding the science behind it and sort of
right,
using that approach, and I really enjoyed like how you were sort of doing both, like sort of the multi well, the regression model and also
right,
the artificial intelligence. So I think yeah, that's something that like people can look into, right? Like
right.
mixed approaches.
Yeah,
So so yeah, for thank you so much for sharing your research. So if we just shift gears, we'll come back to your research in a bit, but uh, so we're aware of your entrepreneurship journey as well with CarboBon. Yes, I got that name right. So so which is an which is a startup that you are involved in.
right.
So if you want to tell us a bit more about that, like, uh, well, you're one of the few PhD students I know, especially in the geography arena, who has a startup as well. So, so yeah, if you want to share with us your journey.
Sure. Sure. Yeah, I would love to. So basically, like the thing, like I was talking with like one of my co-founders, Navid, and like he's also like an environmental science graduate from Washington Lee University, and we were just talking about like exploring ideas like, hey, what can we do like with AI and geospatial data and this type of things, and we were both interested in like carbon credit scenario, and we did some digging around that specific market, and we saw that like in North America, in South America, and in European countries, and even in Africa, uh, it's the market is kind of like well established, and like plenty of projects are being undertaken for protecting the forest, and in exchange of that, like the carbon credits are issued, and the large corporate companies who are committed to reduce their emissions, they're investing in this type of projects. So what we observed is that the South Asian market, like the South Asian region, is kind of like lagging behind on that. And if we look into that, if we'll also see that, like let's say for example, Bangladesh is one of the most climate vulnerable countries in the world.
Right.
So, and there are like lots of climate adaptation projects are ongoing in there,
Right.
but these are like more donor funded, and they
Mhm.
always have to, like the government or even the non-profit organizations always have to rely on
Right.
big donor agencies.
Yeah.
But what happens, like if we introduce an entrepreneurial approach in there, so
Mhm.
that we can protect the forest areas,
Yeah.
number one.
Yeah.
Secondly, we can protect the communities who are
Mhm.
dependent on those forest areas. And thirdly, introduce a sustainable approach of financing, which is like
Mhm.
sustainable ensuring sustainable climate financing for the country as well. So
Right.
that's where the idea came in, and
Mhm.
we were both passionate about environment and also like making an impact.
Mhm.
And then our third co-founder, Protoy, he joined. He's a business guy. He's an MBA from INSEAD.
Mhm.
So then we started digging into it, and then we also tried to incorporate like, okay, so how we can incorporate like artificial intelligence in like using geospatial data
Mhm.
for like assessing the forest health, and also like measuring like measuring the biomass in the forest, which
Mhm.
and overall like ensuring it transparency, because with the carbon credit project there has been like lots of controversies, and
Mhm.
also like there has been questions raised about the transparency and the reliability on the data. So we wanted to make sure that we are ensuring transparency, and also like our methods are clear, and it's reliable. So yeah, so that's where it started, and then we kind of like delved into other um, other type of projects as well. Like, let's say, for example, like we started to look into biogas projects. We started to look into plastic recycling, and
Mm-hmm.
also trying to help out RMG companies in Bangladesh to
Mm-hmm.
like how they can like reduce their emissions, because they like some of them like actually like a lot of RMG companies are
Mm-hmm.
suppliers to the big brands like
Okay.
H&M, like
Yeah.
Adidas, Reebok, and like
Yeah.
yeah, even in the US, when I'm trying to go into Old
Yeah.
Navy and trying to buy a
Yeah.
t-shirt, it says made
It's
in
from
Bangladesh.
Bangladesh. Yeah.
Yeah, and these big companies have like big commitments on like
Mm-hmm.
reducing carbon
Right.
emission, but since they are not directly producing this clothes, it's kind of like falling onto the RMG companies, like are
Okay.
the suppliers,
Yeah.
basically, like let's say in Bangladesh or in
Right.
Philippines or in Mexico, like who are the
Mm-hmm.
biggest suppliers of their brand. So yeah, so they are trying to find ways to reduce their emissions. So we're trying to help them as well, like for carbon accounting, like how much emission they are actually making, like scope 1, scope 2, and scope 3 emissions,
Right.
and how they can address those emissions, and like how they can reduce them.
Right.
So yeah, I think I have been talking for a long
Yeah.
time. So
Yeah, no, that sounds fascinating, and like it's a very different model, and like I haven't seen, especially in the South Asian context, I think it's a pretty like new concept to like push forward. So yeah, that sounds really fascinating. Just curious, like are you guys focusing on Bangladesh for this approach, or
yes.
yeah,
Yeah,
okay.
so right this moment, at this moment, we are focusing on Bangladesh at this moment, but we do want to expand.
Mhm.
But like with Bangladesh, there are like lots of potentials
Yeah.
in this arena,
Mhm.
and it definitely comes up with their own its own challenges as well, because it's a very niche area. First of all, secondly, people actually don't understand the environmental consequences.
Right.
So we need to like we have to spend a lot of time making people understand, like
Right.
because like some of them actually have like a lot of people have the willingness, but they
Mhm.
don't understand the concept, like how things are actually working. So
Mhm.
we actually have to spend a lot of time with our clients
Mhm.
to make them understand like what we are actually doing and what
Okay.
can it bring and
Yeah.
how it's going to help them.
Right.
So yeah.
Right, yeah. No, but good luck with like good luck, best wishes for your efforts, and I
Thank
hope
you.
that it turns into a meaningful thing, and then ultimately Bangladesh also gets benefited. So yeah, kudos to you. So usually, like as you know, that a lot of our listeners are well, aspiring scientists, or like trying to like understand the geospatial field better.
Right.
So do you have any advice for them in terms of like uh in terms of like maybe academia, or also like when they're doing research in this field, if you have any guidance or advice for them? Yeah.
Yeah. Okay. So I would say like I would start from an approach that like correcting my mistake, like correcting my mistake means like the approach I took, I felt like I if I could start over, I would do it differently. So
Mhm.
I would start with that. So basically it's very important to have some sort of subject matter expertise, because at the end of the day, the GIS, remote sensing, machine learning, artificial intelligence, everything is a tool,
True.
but how you are using that tool, that actually matters. So where you are a, um, strong subject matter expertise in could be any field, could be hydrology, could be forestry, could be land use, land cover change, could be could be anything. But it's important to like narrow down that area first, and side by side you need to think about how you can incorporate GIS and remote sensing in that type of studies. So that's one thing I should emphasize on. The second thing is if you're like I didn't do it, but I strongly recommend you to do like learn at least one programming language. It could be R, it could be Python, So just learn whichever you feel comfortable to work with. So it's very important, especially if you are coming to graduate studies, and like even if you are like going to jobs, like
Mm,
knowing one programming language, it's not only about learning how to code, but it also gives you a pathway to have like the computational understanding of how the software works or how the logic works. So it's really important to understand that as well. So
mm,
yeah, that will be my second advice. And third advice is talk to people, like
mm.
connect with as many people as you can, not just within your field, but beyond your field as well. It broadens your horizon, and you never know which opportunities may come up. And yeah, so these are my third advices.
Right. No, no, that's absolutely like that's a sort of like a recurring advice that we're getting in this, and we really want to put that out there that this is definitely important. Is sort of the value of networking, and not only for like in terms of like opportunities, but also in terms of like just expanding your
Right,
horizon. Like I always share a story like I with my juniors as well, is that the first time I went to an international conference, the only thing I got out of that conference is that how much I do not know, like how
right,
much
right,
that I think that sort of really makes you sort of like that's like a humbling experience, which I feel
right.
also.
Right, right. Yeah, and I
So
think like for networking, like you cannot expect something in return. Like if
yeah,
you're expecting something in return, like you're not doing the networking properly, just go out and like
right.
meet people, talk with them.
Yeah,
Like, and then you will know something that you didn't
right.
know. So that the
Yeah.
thing just you mentioned, like that is very important.
Yeah, yeah, exactly. Yeah, I think that's very important. So we just want to like sort of we're sort of in the end, but I'd like to sort of circle back to your research. And so I know that you're already a PhD candidate, but where do you see yourself in like I don't want to say 10 years. That's
Job
I feel
interview
like that's
question
too
coming
far.
up.
Yeah, okay. So maybe like 3 or like 3 or 5 years.
Uh, I would like to see myself I think I was recently sharing it with someone else as well. Like I would like sort of want to see myself in a more like technology leadership kind of position where um like I love doing research.
Mhm.
So and I feel like the research is the way, like wherever you work, like whether you are working in the industry or in the academia, research is very important. So I try to keep myself updated, not only not only in the arena of geospatial technology, but in the other fields as well. So I would love to see myself in a technology leadership type of position, so that I can um, uh, materialize my ideas into the real
Right.
world and solve real world problems, small step at a time. Like
Right.
I don't want to, like I don't
Yes.
want
Solve
to
everything overnight.
yeah, and like it's not happening. Like my
Yeah.
biggest learning from my PhD is that you always have to start small. Like you have to
Right.
solve a very small problem, and then one by one you can like approach the bigger ones.
Right.
So yeah, so that's where I want to see myself
Right.
in, let's
Yeah.
say, three to
So
five years.
last question, because I feel like we haven't talked about this in our podcast, but I think you're the perfect person who can answer this. So I know a lot of people are like, especially when they sort of are looking for academic positions or whether they want to do a PhD, they're sort of concerned about what after PhD. This and the main sort of question I hear recurring is like industry versus academia. So, if I've read you correctly, you see yourself in sort of like an industry position, so or
Yeah,
industry come research position,
right.
right? Or research government
Mhm.
position. So, like, what was your like what went in or went through your mind like when you thought about this, or how would like a typical graduate like think about it?
So I think m- the reason it like I am like So first of all, like I just want to like repeat myself. Like I love doing research, so it could be academia, could be research, but I'm more lean towards the industry because I feel um, like especially in the geospatial arena, lots of research are taking place,
Mm,
but they are not being materialized into the field. So that's why like I feel like if I go to the industry, I would have more scope to like quickly implement them.
mm,
So that's one of the reasons. And like because I see like every day, I see like even in the LiDAR arena, I see a lot of good papers, which if they are being if they get implemented in the field, it would reduce workloads. I think it would reduce workload by a lot, like reduce
mm,
man hours even. But they are not being implemented, so there's a gap, like in terms so there's a gap there.
mhm.
So that's why like I'm more lean towards industry, so that like I can like work fast, and like I can also get those products out like as soon as possible, so that and I can see the results quickly, because with the academia
Right.
sometimes things get a bit slow. And
Mhm.
so yeah, so
Yeah,
that's what my philosophy is. So
right. No, that definitely like yeah. So I feel like there are people who would like sort of maybe choose this or that, or it's not a this or that question.
right,
Sometimes it's also about like what's available, the
right,
opportunities that are
right,
available after graduation and all that. So but like as you said, like it's always important to sort of try to understand what you want better, or as you are saying that you enjoy research, but you also want that implementation
right.
side of things. So yeah, that's great. So thank you so much, Gunjan Dada. It was so nice talking to you. I really enjoyed this podcast.
Thank you.
So if you have any last words for wrap before we wrap
No,
up.
yeah, I think like please watch this video.
Yeah.
Yeah,
Yeah.
and I think this type of platform is really important to understand, like especially for this aspiring graduate students. Sometimes like I know it can be very confusing, like what type of research they want to pursue. This type of research, this type of talks kind of can give them some sort of guidance, like which directions to go towards, and whether, and also like evaluate their interests as well. So yeah, just and also like keep exploring options. There are like plenty of resources out there. Do your own research, and yeah, and I think subscribe to this channel.
Yeah. Okay, I think that was my job, but thank you so much for doing my job. But yeah, of course, just restating what Punjo Dada was saying, that uh, like it's really important to and that's the whole point of this channel, sort of. If we have if you if the aspiring scientists have like a platform where they can at least listen to us or interact with us through this channel, I think that really helped us. Like I know when I was looking for my PhD admissions, I know that I discovered the research topics like almost like going through professor's profile and seeing what they were working in. But I really didn't know that maybe a lot of my seniors were already working on that, but I never got to know that. So
Right.
that's the whole idea of this platform. So yeah, as Gunjan Dada already said, maybe subscribe to the platform, and we'll try to bring in more experts in different industries so that we sort of cover a lot of width of like applications. So thank you so much for coming to my podcast, and yeah, thanks.
Yeah, thank you.